All right. Well, thank you so much, everybody, for your time here. You have met me already, since this is going to be very cozy. I'm Alberto from the company Cegasa. And normally I need my glasses because I cannot see anything. There you go. All right. So today what I'm going to do is present the company, Cegasa, and also our lithium range. Notice that Cegasa is not only into lithium. We produce in different technologies, okay? But this is what we are presenting today. I guess is the thing that is most related to your businesses, but we are not exclusive to that. In fact, I'm going to introduce a little bit the company so you know who we are. Cegasa is based in Spain. It was originated in Spain, the north of Spain, in 1934. It's quite an old company, 85-year-old and going on. And the company started with the alkaline cells, okay? In fact, it became an icon. It's quite an iconic brand, not only in our home brand, in our home ground, but also in Europe in general, because of these batteries, these alkaline batteries that you could find everywhere in the shops, in the supermarkets, etc. And for many years, that was the core business. Okay, as you see, the evolution has been. Well, I mean, you can see the different logos from the different decades that we were working, but also the evolution of the products that we were doing. Back in the 60s, Cegasa started developing the zinc-air battery technology. Zinc-air is not a new. It wasn't new at the moment. In fact, the origin of the zinc-air is probably the early 1900s. But Cegasa was the one that put more effort into it. They developed the technology, and we could say that this technology that is currently being produced still, we are covering practically 70% of the world market, okay? And we are not covering more because one of the applications, which is the ER8, we don't do those batteries that small. We start with slightly larger batteries, but in the rest of the range, we are world leaders. Those batteries are very adequate for applications that require very low power, but for a very long time, okay? So they are used in different industries like railway, emergency lighting, electric fencing, parking meters. I mean, there's a whole bunch of applications where we produce this battery for. The evolution kept going, and we arrived at 2009. In 2009, Cegasa created their own division for the study and development, research and development of the lithium range. So it's been more than a decade working on that with a series of products that have been evolved as well. And we reached nowadays, our final change of logo was in 2018, where we launched most of the products that you can see here and that we are going to talk about today. So a little bit more about us. Again, we work in many industries. Even in the lithium, we have some products that we are not offering in Australia. That's the case of example, of the traction. We do a lot of batteries for electric vehicles, but power traction. So we're talking forklifts and stuff like that. And we work directly with the OEMs. But the batteries in all the technologies, as you can see, they apply to many different industries. Due to this long history that we have developing different technologies, applying them, we own our own laboratories, which are of the highest standard, to the point that they have been approved for European certification, meaning that even third parties come to our labs to do the testing and obtain the certification on a European level. And of course, we are backed by our own engineering team. We have people dedicated, let's say, specialists in every single component that is part of the battery. So we have real specialists in every topic. And now, what you wanted to know, I guess, is the different lines that we are offering. Okay, here in Australia, we are offering these 3 lines of products that we could identify, let's say, with the size of the systems that we are going to be applying them. So these ones obviously are for the smaller systems. This could fall into the medium-sized systems, and the last one falls into the larger systems. Okay. And I will start by the smaller ones. There you can see them live. In fact, they are not dummies; they are real ones. I'm not going to carry them around because they are a little bit heavy. But well, if you want to touch them a little bit later, you can go for it. Okay. You will see that all our products on the lithium range, they have the same concept. Okay. The first thing that they distinguish them is the flexibility. I mean, we want to get as close to the application as possible. So, I mean, if the requirements for the particular application is this one, in terms of size or in terms of voltage, we want to get as close as possible. Sometimes it's not possible, but the fact that we are working on modular systems, it makes it easier because we keep piling the modules until we arrive to the requirements of the system. Another characteristic is that they are fully scalable, meaning that once you have a system installed, if later on you need to add extra capacity, well, you just keep adding more modules, and you can keep increasing the size of the systems. And of course, all the advantages of the lithium that are very well known. I think the conversation of the industry has changed a lot. Not so long ago, we were discussing if lithium was better than other technologies. Then we started to discuss inside the lithium if one chemistry was better than other. Right now, it's very accepted that lithium is quite capable of doing the stuff. Inside of the chemistries, especially for stationary applications, probably LFP is the one that is taking the share. We as Cegasa, we are chemistry agnostic, so we try to use the best chemistry for each application. Although I have to say that all these products are based on LFP, all of them, okay? We work with other chemistries, especially in the traction and mobility, but in the case of the products that we offer in Australia, we are talking always LFP. Here you can take a look about what one of these eNerlits looks inside. In fact, the modules are always similar. They change in the size, okay? But well, they are based on cylindric cells, and they are equipped with their own BMS. That, of course, whose function is to offer the protections to the battery. This is the list of protections that they offer. So, in terms of voltage, in terms of current, in terms of temperature, in case of short circuit, and they have always a small. Depends on the product, but a small ability to offer some data as well, which is quite important. This is the range, the current range. Okay, difficult to see. Luckily, you have the catalogs in the back, and you can check there the specs for each one. But what you could see is this range. If we say that it's flexible, is because we are offering them in 4 different voltages. We are talking 12, 24. 36 and 48 volts. We call them of general use, okay? Inside our company, we also say industrial use because most of the applications that we find are from the industrial world. But again, there are batteries that can be used where a battery is used. They are a perfect replacement for lead-acid batteries in many cases. So wherever you find a lead-acid battery, you could fit one of these with the lithium advantages, okay? They come in different sizes inside the voltages as well. So, as I said, trying to adapt to find the perfect fit with the application that we are looking for. Depending on the model, they can be connected in parallel. and depending on the model, between 6 and 8 modules. Okay. As an example, for example, the last one, the one that you can see here, this one here, the 4855 is the one here. This is the equivalent of 2.5, slightly more, 2.5 kilowatt hours. This one can be set in parallel up to 6 modules, meaning that any application that can go from half a kilowatt hour to 15 kilowatt hours could be covered by this range of batteries in the different settings. We have seen, for example, this battery set in stationary systems. We have seen them. But again, I mean, the range of uses is unlimited. It depends on really how you wanna use them. Okay. As an example, something Beiwa can tell you even more. The most demanding in Australia have been these ones. The final application, I don't know. Maybe Durmush can tell us. And well, this is we are finding that they might be using in boating, caravaning, stuff like that. They fit very well with Victron. Victron is a partner of us in Europe as well. So, well, off you go. I mean, you just have to find the application and then go for the battery. How do you connect these batteries? Well, it's an absolutely normal parallel connection. It doesn't require any special equipment, this sort of screws and washer. And well, you connect just one to the other and off you go, okay? You will see that the battery has another extension, this output here, okay? That you can see better here probably in the photo, okay? This is the output that provides some sort of communications that I will explain slightly later. But as referring to the power, as you see, just a plain connection, no difficulties there at all. What is recommended, depending on the systems that we are working with, is that we need to find the balance. I mean, lithium batteries, probably the challenge that they have to face is the balancing of the systems, that the cells are equalized, that the different batteries are equalized. So we, especially in stationary systems, we recommend the use of a busbar. In this case, we would go and connect each of the battery independently to the busbar. This way we ensure the balancing of the system. Or in some other applications, we could do it directly with module after module, and then have the outputs to the system, like if it's shown in the picture. For example, in terms of mobility, this is very accepted. It works very well. But again, you have to look into the application and consider if it's necessary to go through a busbar or not. Okay. Again, when we are talking about the correct balance, it is very, very important to equalize all the components of the system. So if you are connecting every single battery to the busbar, for example, use the same type of cable with the same conductive material, and the length is quite important. At the end, we are looking into have the same resistance on each battery. So one of the mistakes that we have seen somehow is that maybe different batteries have different length and they offer slightly less resistance, and at the end you are just causing some some imbalance in the system. Okay. In terms of output of the battery, well, as you keep connecting in parallel, you not only are increasing the capacity, but also you are increasing the current that they produce. There is a limit. In this case, is 4. So it's a security limit that's set in the battery, meaning that up to 4, yes, you are multiplying the current, but the moment you go over that number of units, it will stay at 4p. It will stay like the same power as the same current as 4 units in parallel. Okay. Each of these batteries, considering the range of batteries that we have, each of them has its own technical specifications, it has its own values. I'm not going to go over them right now, but well, all this information is fully accessible, of course. Okay. These are the values that generally, just to check model by model. Normally, when you connect them to the inverter, the only thing that we need from the inverter is just to set variables in terms of voltage and current for charging and discharging. Okay, so these batteries are used as unmanaged, let's say, like if it was a lead-acid battery. I love the names that. I mean, I don't know in the rest of the world is the same, but here in Australia there are so many names for dam batteries, unmanaged batteries, self-managed batteries, and I guess there's an explanation behind each of them, okay? We internally, we say without communications or without communications, that's what we say. Well, in this case, it's without communications. So as such, they are treated as an unmanaged battery. And in fact, it's important to say, we'll repeat it later, but it's important to say that whenever we are connecting the settings in the inverter, we are choosing the option of lead acid. We are not going for lithium because the inverters might have a special option for lithium that might have some other requirements, but because we are using them without communications at all, we set the inverter as lead acid, and then we introduce the values corresponding to the battery itself, okay? It's quite an important point because sometimes it has caused some confusion. This system here on the screen, that was set in Spain. This inverter is not available in Australia. It's a 24-volt system. It's covering sort of a shed or a hut. And as you see, well, not much difficulty there in order to install the system. But again, it's not the main use. It's not the main use of the batteries. I've got to say that we have many other uses for these ones. So I guess you are going to ask, okay, if they have some sort of communications, why are we using them as dam batteries? Well, we have this accessory. We call it display. It's just a display. There's no screen in here. It's just all LED-based, okay? And connecting this to the different modules, we can obtain a little bit of information about what is happening. Something that normally you wouldn't be able to do it with a lead-acid battery or something. At least with this small gadget, you just connect it. It's an accessory. Again, it's not mandatory to have this to set a system, but it helps a lot, especially when you are setting up the system. It can help you with the information that it provides. Okay. So you can see it better here. This is the screen that you have in there. Well, the first what you find is a switch. In fact, the moment you plug the display into the battery, if there's any action in the battery, if at the time the battery is charging or discharging, the display is going to turn on by itself straight away. Okay. You can do it manually in case the battery is idle, but the function of this is if the battery is working, the display is going to be on. So this is the first thing. Second thing, there is little bicolor LED. It's telling us the situation of the comms. So it might be that there is something wrong with the battery, then it will be a red light saying, okay, there's really something wrong in there. Hopefully that's in the minority of the cases. In most of the cases, it should be green, indicating that the battery is working properly. And then, just by flashing or being solid, it's telling us if the battery is properly charging or discharging at the moment that the display is connected. More information, and probably the most important that we get out of it, is the state of charge of the battery. Okay, this is something that in lead-acid we compare with voltages. Here we can have a quite accurate measure of what is the state of charge at any moment. Okay. Apart from that, the display incorporates a security measure, which is the moment it reaches 10%, It's like your phone. On your phone, it says, hey, be careful that you are running out of battery. Well, in this case, there's this bit of the battery turns on, which is red, indicating be careful. And there is also an acoustic signal indicating, just in case you are not around, at least you can hear it, that the battery is going low, okay? And then there are 3 ways just to turn this off, okay, just to do it right. The obvious one is that the inverter has located that, and then it starts charging instead of discharging the battery. The second one is manually. You are there and you say, I don't want to hear this anymore. So you just press the button and then get rid of the warning. And the third one is probably the least recommendable, is just leave it to discharge. And then when it reaches 5%, the battery activates, the battery itself, the BMS inside the battery, activates the self-protection and shuts down. So the battery doesn't get depleted, okay? And in this case, of course, the warning gets off as well, okay? Because the state of charge is, again, probably the data that is more interesting. There are 2 ways. I mean, this one is more into 10%. And again, it's a color system. So if everything is good, it's green. The moment it goes into the 20%, it gets more orange. And the last one is a red, saying, be careful, you are on the 10%, you might get into trouble then, okay? Applications, as I was telling you before. Those on the screen, the ones in the picture, they are all real applications that we are servicing at this moment. In the case of the scrubbers and the sweepers, we are working with OEMs on European level, and they are incorporating our batteries into the new models, and in some cases even branded as the OEM brand. We've worked with auxiliary equipment that they put in ambulances or in trucks or in caravans, all-wheel drive vehicles. This one is a special project that we are doing with an AGV with these Caterpillar wheels. Again, the applications, you find them, you have a battery, and all of these, at some point, they had a use of these batteries. Some of them are quite interesting that I had never thought of. I mean, for example, when I saw the toilet cabinets, I had to ask. I say, well, what do you do that? And well, these portaloos that they exist in different industries, it looks like they come with more and more equipment. They are very self-sufficient at the moment. They have batteries, or off you go. I mean, at the end, it's a battery, okay? And just to give you an example, as a replacement of a lead acid, this is a golf cart that originally was designed to be on lead acid. The owners, that was back in Spain as well, they said that they wanted to change the fleet. Let's see if it could be adapted to their fleet of golf carts. And well, this is the solution that was presented to them. As you see, it takes literally half the space of the lead acid, and in fact is providing much more capacity than the ones that they were before. And well, they are very happy with the solution, and now they are changing the whole fleet of their golf tracks. We believe this is really what the future is going to be. I mean, not only replacing them, but the new models are going to become more and more electrical with lithium batteries. And that's it in respect of the eNerlit. So I don't know if you have any questions or you want to wait.